code takes forever, the HT-sync count.
Well, you're supposed to submit it to the cluster. If you're running it on your, like that, then it will take forever.
If I do it the other way, will it be faster?
Yeah, submit it to the cluster. I told you it should be in an LSF file. It shouldn't be run one by one on your terminal.
I'm just trying whether this code works.
Well, now you know. Okay. Today we're going to talk a little bit more, get deeper into our control functions and loops and control structures. So there's a bunch of stuff that will, again, it'll be new to you, but don't get, if it's overwhelming, I can always slow down. And the big picture here is to try to understand the concept. There are many ways of doing the same exact thing here. So we're trying to run a loop, or there are multiple loops. There's multiple ways to make the control in a program flow. But what you want to understand is just the concept, and then we can go deeper and understand what the various ways are for what we mean by each of these. Right? So here are some of the examples of control structures. So control structures allow you to control the flow of the program, flow of execution, depending on the runtime conditions. For example, if you're writing a piece of code, sometimes you want depending on the condition, you might want to change the command you want to execute. For example, the most common one is if-else. So like if something is true or if something is false, then you want one thing to happen, versus if the condition is false, then you want something else to happen, right? So that's done by the basic if-else condition in a program. You have the for loop that can run for a fixed number of times. So supposing you have a bunch of statements that you want in your program, a bunch of lines of code that you want to execute multiple times, and you know a priori how many number of times you want them run. So you can say for a variable until it reaches a certain number, let's say 100, keep running this loop. So the number goes from 1 to 100, and your loop runs 100 times. While loops are usually there for when the condition is true. Until that condition is being met, you continue to run a set of statements. Right? So that's the purpose of a loop. Any loop here is to run a group of statements for a specified number of times, or until a condition is true, or just an infinite number of times, which is a repeat loop. Right? Can you guys think of an example where you might be using a for loop?
So earlier we had made that for top hat alignments. We had done it where we did like a bunch of the same set of 3 commands for every file. You could just loop that.
Right. So supposing you knew how many files you had and you knew their names, then you could store the names in an array and then just run that in a for loop, saying that for a number of files was 1 to 15. Run the alignment 15 for each file using the given command.
So can you store in that array of file names that would link to objects that store the file information? So like if you had XYZ as objects full of data, and then you put that into an array, you told it to call a for loop on the XYZ.
You can call them, yeah. You can call, but depending on which object is stored where in the array, you can specify them. So the objects for the first file are stored in the first location, second for the second location, and so on and so forth. So you can reference them in your command. So that's the whole point of having these control structures. And like I said, there's for, there's while, there's repeat. And when you usually have a repeat, you have a break. So repeat basically says keep doing this infinitely until you encounter break statement. The break statement then breaks out of a loop. It's usually. Sometimes you also have a next statement, which helps you skip to the next iteration. So supposing you want to run the loop 100 times, but you don't want to run the 6th iteration. So you can check what your iterator variable is, and then say if the iteration number is 6, then next, meaning don't do anything, come back to the next iteration. So it'll go from 1 to 5, and then 7 to 100. Does that make sense? All right, so we'll go over each of these in detail. And then there's a return statement which is used to exit a function. Okay? We'll talk a little bit more about functions and what they are as well later on. Okay, so let's go and look at each one of these in detail. Right, so first, if. Right? So the if statement begins with this syntax where you have if, you have these round brackets, then you have a condition, then on that condition you have condition, you have those, so the condition amounts to a true or false, right? So the answer here would either be true or false. For example, one condition could be, I have a variable called I, and we get the value of I, and we don't know what it will be, and so we test the condition. If I is less than 5, then we do something here, else if I is greater than 5, then we do something else. Right? That's just an example. I'm just choosing a random variable here. Right? So till here, any questions? Do you understand what the purpose is for a control structure in a program? Yeah.
When you so you have the condition and the if
Yes.
round brackets, then you have
Yeah.
this other.
Well, so this whole thing is going to be replaced by the condition.
Yeah, let's say it's like x equals 4.
Right.
How do you actually get it so that it will fall inside of the if statement? So I did something in the practical. There was like 2 commands in one, and sometimes it didn't read it. And then when I copy pasted it, it was like 3 tabs over. So like, how do I go from that pointed bracket to the subcommand within the if statement so that it considers it part of that loop as opposed to like a separate command? Like this actual type strokes.
I'm not understanding.
Yeah, I guess I'll have to show you
Okay.
what I mean.
We can go into the specifics, but basically, if you have a condition that is met, it will go here. Otherwise, if the condition is not met, for every other outcome, it's going to go here. Right? And you can also have multiple conditions chained. So, for example, if condition 1 is true, then do something else. If condition 2 is true, do something else. Finally, if neither condition 1 nor condition 2 hold, then you do something totally different. Right? So that's another way of controlling your flow of the program. Here's an example. This is a valid if-else structure. If x is greater than 3, we're going to assign the variable y the value 10, else y is going to be assigned the value of 0. Right? Fair enough. You're basically trying to get the value of y to be equal to either 10 or 0, depending on the value of x. Does that make sense? Everybody with me so far? So this one is another example of the same thing, except you took the declaration part outside, and then you just say, depending on the value of x, return either 10 or 0, and then that return value is assigned to y. It's doing exactly the same thing, except it's like a shortcut. Are you following me? Yeah? So here you take the declaration of y inside. Here you're just saying, whatever is the outcome of this if statement, just assign that to y. And it's the same exact thing, just done differently. Okay. Alright, so of course the else clause sometimes is not necessary. You can just have a condition of if on its own. If condition 1, boom, then no need for else. You can just say if condition 2, boom. Right? So you can also work like that. It could also be a bunch of if statements without any else. Okay? Alright. For loops. So now that we know that there's programs we can write, then there's loops, then there are all these if statements that can help you control the flow of the statements. There's also this thing called as a for loop, as I said. It takes an iterator variable. So first thing to understand is what is an iterator variable? So iterator comes from the word iterations or iterations, depending on how you pronounce it. So are you guys familiar with what we call as iterations or iterations?
No, repeat.
Yeah, repeat. So iterate or iterate basically means that you're going to repeat something again and again. Okay. In this case, the variable that is assigned to iterate is I, and it takes multiple values depending on which part of the loop it is in. So if it's in the first iteration, it's going to start from 1, and then it goes all the way to 10, where it takes the value 10. Now for every value of I, a bunch of statements within these brackets are executed once. So for every value of I, the following statements will be executed once. And then the value of I increases to the next value, and then again this bunch of statements are repeated, executed. Okay, so here for example we're saying for I in 1 colon 10, meaning I is going to take on the values 1, then it's going to be 2, then it's going to be 3. And for all of those values we're saying print to I, so it's just going to be a bunch of printing of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like that. Does that make sense?
Yes.
Clear so far? I mean, obviously print I is a very basic statement. You can also add a bunch of other stuff here that you want to be repeating again and again. The key thing to realize here is that the iterator variable I has a defined set of values that goes from 1 to 10. Okay, that's the part that you need to focus your attention on. So you can also form loops on strings or characters. So for example here, one way is that you can say, let's say x is a vector which has 4 characters in them. What are the 4 characters? A, B, C, and D, correct? So here what we're saying is that we're going to have a loop for I, which is the iterator variable, from 1 to 4. And earlier we were just printing I, now we're saying print x of I, meaning whatever is in location I. So for location, when I is 1, we're printing x of 1. When I is in the next iteration, I is going to be 2, printing x of 2.
So it's A, B, C, D.
So it'll be printing A, B, C, and D in that order. A, B, C, and D. Does that make sense? Yeah? You're changing the value of I from 1 to 4, and you're printing the x value at 1, 2, 3, or 4. Okay? So that's just a simple thing. Another way is to use the function called seek along x. So what seek along function does is that it returns essentially, it takes a vector, it gives and it returns the integers from 1 to length of x. So what is the length of x here? Length of x is? What is the length of?
4.
There you go. Length of x is 4. So seek along will give you numbers starting from 1 to length of x, which is 1 to 4. Okay, it's the same exact thing, except one thing is that supposing this is a better way because you don't have to worry about the numbers in advance. You don't have to know the length of the vector in advance. You can just say seek along x and then it automatically goes to the length of that vector. Here you kind of have to know what is the final number, which is the length of x beforehand. Okay? Alright. You can also say for letter in x, which is another way of just saying, okay, so letter is now the iterator variable. So I could say for letter in x, meaning start from one letter, which is A, B, C, and D directly. So you can use the letters in x as iterator variables themselves. Okay? Does that make sense? Yeah? So the objects in x, each of those characters become part of this iterator variable. This letter variable first becomes A, then it becomes B, the value then C, and then D, and so forth. Okay? So that's another way of writing a for loop. So these are all examples of how you can write a for loop in multiple ways. It's doing the same exact thing, but you're doing it in different ways.
And the difference between the first one and the last one is you just don't have to put this into another.
Exactly. So you don't have to put the brackets. Right?
the big bracket, did you have to put yourself or the program put it for you?
No, you have to put it yourself.
The thing.
The curly brackets, yes. Yeah, these brackets you have to put yourself. But sometimes you can write an entire statement in one line. For example, if there's only one statement after a for loop, you need not put any brackets. You can just put that statement in front of the loop, and it just assumes that this is got to be run 4 times. Okay?
Why is it like for the length of the vector?
Yeah.
It's C-long.
Yeah.
In some languages, length is much simpler. This is
No, there is a function called length. You could also say for I in 1 colon length x.
okay.
So you can say x, a length of x. But C-long generates 1 to that number automatically. So it's a wrapper function for 1 to length of x. You can think of it that way.
Makes sense.
Okay, next. Nested for loop. So what is nesting? Yes.
More than one for. So for every class, for every student, and then for everything we have on the so 2 for.
So nesting is a concept. Very good. Nesting is a concept where you can put one loop inside another loop, right? So that, and in this case, for example, there's an outer loop, and then within that loop there's an inner loop. So usually, if you want to do a bunch of things, and then for those bunch of things you need to do another bunch of things, then you can use this concept called as nesting. And the classic example is, supposing you have a matrix. The matrix has rows and columns, as we know. So first thing we do is, well, we say for every item in a row, do. So for I in 1 colon number of rows, and then for that, so we're going row-wise, but then for each row we also have to go column-wise. And so we say for j in 1 to the number of columns of x, print x I comma j, essentially printing every element of the matrix. All right? So I goes from 1 to 2, j goes from 1 to 3, and then we end up printing every element of when I is 1, then you print 1 comma 1, 1 comma 2, 1 comma 3, and then you go back, I changes the value from 1, now it becomes 2, then you come back and you print again for I is 2, you again go for j to 1 to 3, so you go print 2 comma 1, 2 comma 2, 2 comma 3. Okay? So essentially you cover all the elements of the matrix, and that's just an example of a nested for loop. Question? Did you guys follow this? Yeah? No? Everybody? So be careful with nesting though. Beyond 2-3 levels, it's often very difficult to understand what's going on. Even 2 levels, I can sometimes find it's a little confusing. I mean, obviously the matrix example is simple. You're just printing the elements of a matrix, so you can understand for every row there is columns. So I would rather just write once and go for every row. I go column, then go to the next row, print out the columns. But now if you add another dimension and you add a third level, then you just starts to get a little confusing. Just be careful when you're nesting. Okay, while. So while loops, just like for loops, the only thing is that they begin by testing a condition. And if that condition is true, they execute the loop body. Once the body is executed, condition is tested again. If that condition is true, they execute the body. So here is the body of the loop. So this is the body. Everything inside the brackets is considered the body of the loop. This is the first statement where the condition is tested. And then notice that the iterative variable here lies outside the loop. So it has to be defined outside of the loop. And also notice that there is no auto incrementation of your iterative variable. You have to manually increment your iterator variable. So unlike in a for loop where the value of I changes automatically and goes from 1 to 10, in a while loop, the user has to increment the value inside the loop. Okay? let's go back and look at the for loop once again, just so that this difference is clear. In for loop, your I is your iterator variable, and it is automatically incremented. You don't have to anywhere say I is I plus 1 or increment I. It just happens automatically in this one statement. All right? Here, on the other hand, in a for loop, or a while loop, sorry, you have to not only define your I or count, so count is the equivalent of I here. It's being defined outside as 0. It's tested here, and then it is incremented here. So all of those things are done automatically in a for loop because, yeah, so the equivalent for loop for this would be for I in 1:10, print I, and done. So it's a lot simpler, but while has its advantages, and this is how you write a while loop. Count is count plus 1 is the way where you increment the value of this count now becomes 1 more than its earlier value. So the earlier value is stored here. Here you're saying add 1 to it and then assign it back to the same variable. Okay? Questions? Yes?
So kind of going back to that example where like if you wanted to skip row 6, for example, or like
Yeah, so
whatever.
you can just say if count equals 6, then you just type next. If count is 6, then you say next, and then it just skips the rest of the, so that'll be the first statement here. You can say if count equals 6, then next, else print count.
So that would have to be nested in a while loop because you wouldn't want to do that for number 6.
Right,
Yeah.
right. Okay. All right, so that's a simple, here's another example of a while loop. We'll do this in the actual statement, but notice that z is your variable that is going to be tested, and you can test multiple conditions for z. So here you're saying as long as z is greater than or equal to 3, and, so notice the and sign is 2 ampersand symbols. So that means the condition checking for and z is less than or equal to 10, then you continue to do this, and here you change the value of z in the middle somewhere here. So you either increase it or decrease it depending on a coin flip, and then once that value does not satisfy this condition, that is when you break out. So you'll break out, when you break out of the loop or when you get out of this loop, the value of z would either be less than 3 or it's going to be greater than 10. Alright? And inside we're just flipping a coin and we're saying if that coin is 1, increase the value. If it is not 1, then decrease the value of z. Don't worry about it, it's fine. It's just-
I'm trying to think why would I use this.
Why would you use it? Because it's fun. That's why you use this.
Okay.
Well, it's literally a coin flip. So our binom is a random binomial distribution, and you're basing it saying that there's a 0.5 probability of it being either true or false, and so the coin comes up to be either 1 or 0, and then if it's equal to 1, then you add a value 1 to z. If it is not, then you subtract the value from z. Z starts out as 5. So if there are 2 coin flips consecutively where you don't get the value 1, then z is going to become less than 3, and we're going to exit the loop. If there are 4 coin flips where z becomes greater than 10, where it's 1, then you exit the loop on the other side. It's just a fun statement, That's why you do it. It's an example. You don't have to use it. All right. So another thing is repeat. Repeat creates an infinite loop. The only way to exit a repeat is to go with the break statement. So if you have a condition here for the break, and that condition never becomes true, you never exit the loop. That means that your R program is going to be hung. You can force quit it, but I would just say that make sure that there is a likelihood that this condition does hold true for something. Alright? So have a break condition in your repeat loop. That's it. Don't worry about this. Again, we're trying to create this random estimate, and then if that estimate holds for a certain value, then we say break, otherwise we don't break, we revise the estimate. Alright? So don't worry about this, just know that there's a break statement that helps you exit a repeat loop. Okay, cool. So far so good? Questions? Are we clear? Everybody? How about, what do you say, Arpshit? Yeah?
What is the input ABS? What is the mean ABS?
Okay, so now we're getting into specifics. This is what I was saying. So ABS is an absolute value function. Alright? So let's, since you bring it up, let's go over this loop. Because I guess everybody's curious, what is going on? Well, we're defining two variables here, x0 and TOL, or TO1, whatever this is, TO1. The first variable has a value 1. The second variable has a value 10 to the power minus 8. Okay? Then we go inside. There's a function called compute estimate that we don't know where it is, but it's in somewhere in the code. So it computes an estimate for x1. So it gives you a new value for x1. Alright? So this function, you don't see it yet, but just assume that there is a function that gives a value for x1, another value. Right? What we say is if x1 minus x0, so the new estimate minus the old estimate is less than 10 to the power minus 8. So if the difference between the new estimate and the old estimate, the absolute value of that, is less than 10 to the power minus 8, that means we've come up with a very good estimate. Then you can break out of the loop. Otherwise, assign the new estimate to the old estimate and repeat. Alright? So what you're doing essentially is you're trying to get an estimate for for a value, and as long as the estimate function comes up with a good estimate, you can, and the error between the old and the new estimate is small, you can break out. Otherwise, you recompute the estimate and keep doing it infinitely. Alright? Does that make sense?
Yes.
Does that answer your question?
And can we go backward? What was that?
Sure.
Do you mind explain the RBI?
Random binomial function, it's basically you specify a probability, you specify two other things which I forget, how many times you want to, how many values you want as the output. So in this case you're saying I want one output from the function, and it needs to be between 0 and 1, and then the probability of choosing 0 or 1 is 0.5.
Because I tried this and I tried many times, only give me one all the time.
Yeah, because you're just saying, oh, it's only giving you 1 all the time.
Yeah.
Well, your function might be stated, there are multiple things you can do to get different values, including the seed that the function is using. So I can explain this to you in the practical, but if you keep going, eventually you will get some other value. Keep going, you will get another value. Okay, so it's a bit dangerous to use a repeat loop because there's no guarantee it'll stop. Better to set a hard limit on the number of iterations. For example, it's always better to use a for loop than a repeat loop if you're doing the same thing, because repeat loops sometimes can run indefinitely, and that might be a problem. Right? Okay, so after this we're going to talk a little bit about functions. So as we saw, even in the last few slides, we were using these functions, right? For example, ABS is a function for absolute value, or compute estimate. We don't know what this function does, other than I told you that it computes an estimate for a value. But we somewhat get a sense of, there are brackets, and then this the name of the function. So these are functions, right? So functions, we have some idea that they do some things, right? Right? So let's try to learn a little bit more about what functions are and how can we create functions. So functions are created using the actual function keyword. So you say function, and then you have these nice round brackets, and inside the brackets you can specify arguments. So arguments, we can talk a little bit more what they are, but then there's the body of the function, which does something interesting or something that you want the function to do, And then finally, there is an assignment statement to the name of the function. So you're saying f is going to be assigned to a function that does something interesting. So every time I say f with these brackets and pass the necessary arguments, it's going to do something interesting and it's going to return me some value. Okay? May or may not, but it does something interesting. So functions in R are actually first class objects, which means that they can be treated like any other R object. Importantly, functions can be passed as arguments to other functions. So just like a function can receive arguments, it can also be passed as an argument to another function. Function can be nested so that you can define a function inside another function. The return value of a function is the last expression in the body. So whatever is the last thing the function does, supposing it creates a value and says print x, then that value of x is passed out as the return for that function. All right, so the return value. So we'll learn a little bit more about why we need return values and what are functions in general in the next few slides. So let's take a little bit first. Well, let's go step by step. So functions have arguments, right? Not with their within themselves, but functions have these things within these brackets which we call as arguments. So arguments are things that are passed to the function, all right? So they're included in the function definition. These are called formal arguments or named arguments. These are passed to the function and are included in the definition. And so you also have another function called formals, which returns a list of the formal arguments of a function. All right? Not every function call in R makes use of formal arguments, and we'll talk more about that. Function arguments can be missing, can also have default values. So that's next, but for now, there's a function keyword, there's a definition. In that function definition, you have these arguments. All right. So let's take a step and try to understand what that is. So let's talk a little bit about the R norm function, which is random normal, and it takes this argument here called 100. Right? So what does that mean? So this argument 100 means that this function needs a value here in order for it to give you some output. Okay? So what the random normal function does essentially is that it creates a certain number of values that are distributed in a random normal fashion. So it's a distribution. Random normal is a distribution. It's like a random distribution. If you were to randomly pick numbers from a hat, and the probability of getting that number is between 0 and 1, then it'll just give you those numbers as like, okay, so I randomly pick a number between 0 and 1. So what is a number between 0 and 1 that comes to mind? 0.75, 0.5. So that, it says that pick 100 random numbers between 0 and 1. That's what this function is doing right now. Okay? But it needs an argument. The argument here, if you only supply one argument, that would be the number of random numbers that you need from it, that are distributed in a random normal fashion. Okay? So questions so far? We're specifying one argument here. So this is not a definition of the function. This function is already defined. This is a pre-existing function. We know that it has certain arguments. One of the arguments that it needs, the first argument, is the number of numbers that you want from this function. So it returns you a bunch of the numbers which are distributed in a normal distributed way. These are random numbers, follow the normal distribution. And whatever this number is, that's the number of numbers it returns to you. So if I say R norm 2, it's going to only print or give me back two numbers, both of which could be, let's say, 0.5, 0.68. They are from the random, that's from the normal distribution between 0 and 1. Okay, questions till here? Does everybody get a sense of what functions are? If not, it's okay, ask me, I can go over it again. Okay, so let's look at it this way. What would you say if I said I want to write a function to create an average of two numbers? That function actually exists, but I'm going to ask you, what would you do if I said write a function that returns the average of two numbers? How would you go about doing that? Say that again?
So when you make the function, like the arguments you want to create would be like x and y that you put the two numbers in?
Correct. So, yes, and then it returns to you the average. So, how would we create that function? First of all, every function needs a name, right? So let's pick a nice name for this function. What do you want to call it?
Average.
Okay, we're going to call it average. Then we're going to start assigning this function, right? So this means that eventually average is going to be assigned something. We're going to call it a, what are we making this? As a function. Function. Okay, this function needs some arguments. Since this function calculates the average of two numbers, those two numbers will be needed to be passed inside this function, and they will be called the arguments. So what type of arguments would this be?
Number.
Number, or we can say integer?
Yeah.
Yeah? Right?
Real number.
Okay. Let's just say we're going to say int x, comma, y. Right, where int is integer. Okay?
We cannot just say x and y, we have to say int f.
Actually, you could say x and y, and then depending on the value, it would work there.
Is there not a different color? Sorry.
Don't like pink?
No, it's because the light is exactly on the
Okay.
list, so I don't really.
Sure. That's
Sorry.
fine. Right, so now we start the definition of the function. And later on, this definition will end here, curly brackets. So we have two arguments now. How do we calculate the average?
X plus y.
So let's say z is x plus y, and then divided by
Sure.
2. Right, so we do that. And then over here we can say return z, or we can just even, sometimes in R you don't even have to write return z, you can just type out z, and that's it. And that by automatically means that it's going to return z. Right? In fact, you don't even have to do this, you can just write down just this much, and that would be, it'll automatically return the value of this back to whenever average is called. Alright? So this is our function now. Okay, so average is defined. Next step is calling average in our actual code. So now you have an opportunity, say somewhere in your program where you're like, oh, I need to calculate the average of two numbers. So you just say, average two numbers is average of 4, 6. And now this will get the value 5. Alright? Not necessarily do you have to pass 4 and 6, you could also pass it to variables, say I, j, where I was defined 4, j was defined 6 at another point in the code. Okay? And now if you say print average to num, it's going to print 5. Okay? Do you guys follow me? Any questions? Just defined a function. We talked about what the arguments are, what do we do with those arguments. Notice the names that are inside the function versus the names that are passed have no relevance. They could be different names, it doesn't matter. Alright? Yes.
I tried this function, but they didn't divide 2, they just give me the sum. Is there a specific way you have to type and divide?
Yeah. So don't worry about it. We'll figure that out. For now, it's, you can just think of this as a sum function. Don't call it average for now. Call it sum. All right. Okay. Is that cool? Did you put the brackets?
Yes.
Then you put the slash. Still not doing it?
No. I tried times 0.5 also.
And then it still doesn't do it?
No.
Okay, we can solve that later. The point is, this is how you define a function. You made an error somewhere, but either way, this is the definition. So now we know what a function is, what it can do. Okay.
How would you expand this to like more than one number? Or more than two numbers?
Just
So
keep
average.
adding.
Right, but what if I don't know how many numbers I
Pass a
want to
vector.
average?
Pass a vector.
Yeah, so could x in this function definition
Be a vector.
be a vector? So if you
Yeah.
just gave it a single argument as far
Well,
as
I mean,
the-
I think at some point you have to
function setup?
define like a vector, or you can.
if you just say x and x is a vector, then
Well, normally you would have to say. Not sure. I have to look it up how to pass vectors, but the way would be to So you could actually just pass x and be like, for I in 1 colon length of x. And if x is not a vector, then it won't have that characteristic passed to it, and then it will automatically fail. Right? And then you can just say, whatever, sum x. Actually, yeah, we can just say sum x divided by length of x. Right? You don't even need to do this. There are functions available. Good thing is averages are already available as a function, so you don't need to write it. And that's how I would do it if I needed to write another average. Point here is we need to cover a lot of things, so let's get back our attention to what we really want, which is how to define a function and what are the... So everybody understands arguments for now, right? That are passed to a function. Okay. So all of these are basically using the standard deviation function and the R-known function. The R-known function just creates 100 random numbers. SD function on that vector creates a standard deviation. All right, finds the standard deviation. Okay. So you can either call SD my data, or you can say SD x equals my data, or you can say x equals my data, na.rm equals false, or na.rm false first and then x my data, or na equals false and then followed by my data. They're all doing the same exact thing. Alright? All this means is that these are multiple ways of calling the same standard deviation function. Okay? So there's an order of arguments. So remember in our function we created x first and then we added y. So that's the order of the arguments. And that's what a standard deviation function also has an order. It has two arguments. It has the x arguments, which is your data function, and then a logical argument na.rm, which means that if you have nas in your vector, should it remove it or not. And so I would suggest that keep the arguments always the same order. Don't try to mess around with the order. Don't flip-flop the order of the arguments. Even though it will work, it's just easier to remember what the order is. Okay? Right? Sometimes it leads to confusion of what's going on. So, what happens when you pass arguments to a function? Right? So a function definition includes, for example, here's a function definition of a linear model function, and it already includes a bunch of arguments that are to be passed to it. All right? So a linear model function has a bunch of arguments, so a lot of arguments, including formula, data, subset, weights, NA action, method, model, x, y, qr, singular, contrast, offset. So all of these are arguments that need to be passed to the function. So you can make, when you have so many arguments to a function, it's possible to get confused in the order and mix them, right? So like supposing in your head you don't remember whether data comes first or formula comes first, you want to call the function. So the easiest thing to do is to use name of that argument and specify what the value is. So pass an argument as a name value pair. Does that make sense? So you say data is my data. All right? That's one way. if you don't use this sort of name and name or value pair, then what the function does is whatever you pass first, if it is named argument, then it assigns it to that thing, whatever the argument value is to that name. Otherwise, it just starts matching positionally. So whatever is the first thing after a named argument will match to the next thing that is available in your argument list. Does that make sense? So here, when an argument is matched by name, it is taken out of the argument list, and the remaining unnamed arguments are matched in the order that they are listed in the function definition. That should explain it. If it doesn't, I can explain it again. Are you guys following me? Or no?
Yes.
Yeah? What about you? How are you feeling? How are you feeling?
Yeah.
Yeah? Okay. So what this means is that if I have a named argument, I pull it out of my list, so data is gone. So what is left? Formula, subset, weights. So the next thing is y tilde x, that gets assigned to formula. Okay, what's the next thing? Model is false. So model is right here. So remove model. Then 1:100. Where would that go? No, data is already my data. That's gone. Subset. Okay? So what about here? Y tilde x, where does that go? Formula. My data. Where does that go? 1:100. Model is false by name, so it automatically goes to model. Okay? Alright? Are you guys clear about arguments matching by name and then by the order in which they are defined? Okay? Good. So most of the time, names arguments are useful on the command line if you have a long argument list. So what I do is sometimes I will almost always forget the order. So I just use the named arguments very much. Like, okay, you know, I know that this function takes this argument. I'm just going to name the argument. That way I don't have to remember the order. It's simpler. Okay. Yeah. Same thing. Good. That's good. All right. So function arguments can also be partially matched. So this is useful for interactive work. The order of operations when given an argument is check for the exact match, check for a partial match, and then check for a positional match. What does that mean? It means that instead of saying data, if I say dat equals something, as long as there is nothing else with the same partial match, it's going to assign the value that I'm providing to that data. Does that make sense? So here, let's go back. Same example. In this function, if I said instead of data equals my data, if I said dat equals my data, is there anything else that has dat as the first three letters? No. So partial matching works and dat will be assigned to my data. Okay? On the other hand, if there was another argument called date, D-A-T-E, that it's required towards the end, and then I say dat equals my data, now it's confused whether it's dat stands for data or dat stands for date, in which case it'll give me an error. Okay? Are you guys with me? Okay. All right. So here's an example of a function definition. So you don't really need that, you can pass a vector just as value. Function A, now what is the difference between these arguments? A, B, C, and D.
Can you not pass in like a B or C?
No, you can pass in B or C, but this is the function definition. This is not where you're
Or I
calling.
mean like you can't like pass in a B or C that's not warranted.
Actually, you can. So what's going on here is that you're saying that there is something that will be used as a default value in case you don't pass it a value for B and C.
Oh.
Right? So B, C, and D have default values. A does not. So what is a default value? Default value is a value that is to be used in case you call the function and you only define the value for a. So you can only call this function, let's say you call the function and you only specify the value, say a equals 5. And you still call this function f. So you say f in brackets a equals 5. And then within the function you say return a times b. So now, or a times c. Right? Are you with me? No? Here. Supposing we have a function so let's say this is our function, right? So we have a function f which is defined as function. We have a comma b equals 1, c equals 2, d equals null. Alright? Now within this function I'm saying return a star a times c. Right? Okay, that's my function. Now if I go ahead and call function f, so whatever, print, so I'm printing the value or just assigning the value z, f of a equals 5, comma b equals 2. Notice I didn't specify any value for c.
Oh dear.
Huh?
And dear.
Huh?
It didn't specify C and D.
I know. So what happens now? Would this work or will it not work? If I say print z, what will I get?
10.
Exactly. So I don't need to specify the default value for, because I have specified the default value for c equals 2, when I say print z over there, when the value of a I passed as 5, it automatically put the default value of c as 2. Okay? So that's a possibility. And that's why you specify default values. For values that are crucial, you always have a default. Okay? Alright, so sometimes arguments, arguments to functions are evaluated lazily. What that means is they're only evaluated as needed, which is why I can have a value for d as null, and even if it doesn't, or it could just be that d doesn't have any value. So in this case, b does not have a default value, and as long as I say function a and b, even though there are two values required, I only use a square in the definition, right? As long as I don't ask for a, call the function with a value of b, f of 2 works just fine. Because we never use b, we don't care about b. Even if you put it in the definition, it doesn't matter. But if you were to call a f of 2, 4, now you have a problem. Okay? Okay. Alright, so here, print A, print B, and if you call f of 45, you're printing B, but it says, it prints A, but then it says B is missing, with no default. It even tells you that it doesn't have a default value, dude, come on. Okay. Lastly, there's something called as this 3-dot or ... argument. Okay. So usually when you say ... in the chat world, what does this mean?
Etc.
Huh?
Etc.
It's what?
Etc.
Etc. Exactly. So that's what it means here as well. It really means and so on, or maybe, or etc. There's something else that might come in, but we're not sure. You know. So it indicates a variable number of arguments that are usually passed to other functions. So for example, it's often used to extend another function when you don't want to copy the entire argument list of the function. So I can create a new function called myPlot, which is a wrapper around the plot function. All right. What that means is that inside this function, I'm actually calling the plot function. So there are some additional arguments that I have, but essentially all the arguments of the plot function should be made available to my plot function as well. So I use the dot 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 as arguments, meaning that if there are additional arguments that I haven't specified here, then they are just passed as is in this call to plot. Okay? Does that make sense?
Yes.
So you can have an additional number of arguments that you don't even know what might be for plot, because plot has hundreds of arguments. But you're saying, I want to extend the function, I only want to change 1 or 2 arguments, I want to supply 1 or 2, the rest just pass them through all the way to plot and let plot deal with it. I don't care about that. So here's another example of this function called paste, where the first argument is dot dot dot, meaning the first argument is, we don't know how many arguments are going to be there. But we know that we want them separated by a separator, whatever that character is, and then whatever collapse we want, whether we want collapse null or not. Which means, so these are, for example, paste or cat. These functions have these as arguments. So because when the number of arguments passed to the function cannot be known in advance. Because what paste does is it takes the characters that you pass it, or whatever integers, and it puts them together, right? But you don't know how many characters you're going to paste until you actually use the paste function. But somebody has to define that function before, and it needs to be defined. Therefore, paste says you can put in any number of arguments here, and it'll just paste everything together and spit it out. Okay. So here's an example. If you say paste a comma b with separator colon, it prints a colon b. Okay? So that's an example of a paste function. It just takes 2 strings, and whatever separator is there, it puts it together. Now, remember there was a partial matching thing that we could do with arguments. So if remember a date versus data I showed you. So for the dot dot dot, there's a tiny catch, which is that any arguments that appear after the dot 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 must be named explicitly and cannot be partially matched. Okay? Which means that because this SEP comes after dot dot dot, I cannot call SE equals colon. I have to type SEP equals colon. Otherwise, it just assumes that the third argument is also part of this dot dot dot, and it prints out AB colon instead of A colon B. Alright, because it cannot do a partial match for any argument that is after this. So SEP must be SEP, not SE. Okay? It's a small thing, it's just a small catch for the dot 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 argument. Figured you should know. Okay. Alright, so what time is it? How much time is it?
3, yeah.
3. Okay. So we're going to stop here. We're going to do the apply functions next time. Okay. And there's a bunch of apply things, and although it's not a big lecture, alright, let's do the practical. We are going to do the apply functions tomorrow. Okay? Alright?
What? Tomorrow, practical at 2.
What?
What did you say?
I'll send out an email if there's a practical tomorrow, alright? Or a new class. Would you guys want a practical tomorrow and do apply tomorrow, or you want to do this next week?
The next week.
Why?
But tomorrow.
Let's do practical tomorrow.
For the new, so it'll be 1 hour lecture on L-apply. We're going to learn new material.
No.
Huh?
It's a very fast.
I'm going to leave it to me. I'm going to decide and send out an email.